All right, so let's do this one. Remember these? Working backwards on these piecewise functions. Been a long time. This is way back exam number 1. Let's see what you can do. Let me give you a second rather than me just whip it out. See what you remember, what you don't. But all right, so how are we going to figure this out? Well, there's a lot of little things we could do. First off, we could figure out, like, notice that they all have a slope, a slope, a slope, and a slope on the first piece, on this piece. How do I know that's that piece? Because it says x is between -3 and 0. See that? You with me? That is x going between, right here, -3 and 0. Remember, this is a piecewise function. Remember what these definitions mean? It means do this equation when x is between -3 and 0, which is this graph. And then do this other equation when x greater than 0. That's this piece when x is to the right of 0. So remember what those descriptions are, how they're describing the situation? Okay. So, therefore, how do we know which one's right? Well, one thing we could do is find the slope of this piece. How do we find his slope? How do you find slope? What slope? Rise over run. So the slope is rise over run. So what is the rise and the run?
4/3.
Goes up 4/3, doesn't it? Yeah, because that's up at 4 and over 3, right? Up 4/3. So the slope is 4/3. So that's good. That's not good. That's not good. That's good. So we're down to A or D, or of course none of the above. Good so far? We've already eliminated 2 options based on the slope of the first piece. Now what can we do? What else can we do?
Well, the second one.
Well, the second one is really the same on both. 2/3, 2/3. You could find it though. It's not going to distinguish between them though. This goes up 4/6. So the slope of this piece is 4/6, which is 2/3. So they're both right. They both have the right slope. See, because this goes over to 6 here. They both have the right slope for that piece. So what's the only difference? So A and D are looking both correct so far. What's the only difference between A and D?
X is less than 0.
Those pieces, huh? It's the only difference. Which one's right? Does x only go to +3?
No.
Does he stop here at +3? Does the graph come to a screeching halt right there? No way. No way. A it is. Good. Feel like you could do that on the final? Questions I can answer? Austin?
On the graph, there's like a thicker line and a thinner line.
Oh, I think that's just printer issues.
Okay.
Yeah. Not some tricky math thing.
Okay.
All right. Good. Let's move. Okay. So what do we do first to solve this thing? Do what's that? Well, we got to do something about those fractions. So what are we going to do about those fractions? Common denominator. What's common denominator? 21. 3 times 7 is 21. Right? Remember how to deal with fractions? You take the 2 denominators, 3 and 7. 3 times 7, 21. And so that's the common denominator. That's what 3 and 7 both go into. And you go 21, 21, 21. You multiply all 3 of them by 21. That's legal to do. I'm doing the same thing to both sides of the equation. They were equal before. You treat them the same. They got to be equal. Right? And then cancel. 7 goes into 21 how many times? 3. So this comes down as 3 times 4x plus 5. Plus 7 goes into 21 3 times. So this comes down as 2 times 3. 3 goes into 21 7 times. This comes down minus 7x times 7. Let me hold right there. That's the most important. You can all get it easy from here. That's the most important step. Did you all see that step? Is that making sense? What happened there? That's how you deal with fractions, right? Multiply through by the common denominator, top, top, top. Cancel, cancel, cancel. Bring down what's left over. Right? So Just distribute. Now the rest is easy. You could do the rest in your sleep, I'm sure. 12x plus 15 plus 6 minus 49x. What's that? 12x plus 21 is minus 49x. You got x's on both sides, so just get rid of one of them. It doesn't really matter which one. Minus 12x from both sides. So this will be minus 61x. Last step, divide by that minus 61. There we go. 21 over minus 61. Is that there? Oh, no. None of the above. We good? Questions? We good? Remember all that? All right. I'm going to move if you're okay. So this will be, I'm going to dive in. So here, I'll just bring it to a fresh screen here. 4x squared equals 10 minus 3x. So jump these pieces over. So whenever we have x squared with an equal sign, let me write down. So you have a full sheet of notes. I would be making that study sheet right now even, if I was you. I think that would be wise, just on a separate piece of paper right now. Anytime, as we're going through the practice final, anytime you need a formula, just write it down right now. As you do. Don't try to do it the night before. I mean, you won't have the stuff you need. So whenever you see x squared with an equal sign, this would be, want something on your sheet. The steps are, number 1, get a 0. Step 2, you can try to factor if you're really good. That is quicker. Or, if not, you can do the quad, negative b plus or minus square root of b squared minus 4ac all over 2a. Like that. So I'm going to jump these over. And so then this will become 4x squared plus 3x minus 10 is 0. So this, so I'll just go the quad. I know most people like the quad. This is a, b, and c. So plug into the quad. Negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Like that. And then just keep cranking through the quad. That's going to be what? Minus 3 plus or minus square root of 9 minus 160. Is that right? Did I do that right? Minus 4. No, I did not. Do you see my mistake? Do you see why I just caught my mistake? So let me just, this is what you want to be doing for yourself. I right away looked at that and went, negative? I mean, that could be, but that's a little weird. That's what caught me. Right? Is I went, oh, wait a minute. So this is the kind of thing you want to do more and more as you move in the line, math and science, is become a self-critical worker. That's one of the skills you want to obtain as if you're going the way of math science. You can't be perfect. You've seen me make tons of mistakes. But there is something where you look for weird things. So like that is a little weird, getting negative. It could be, that's going to be imaginary. And I go, wait a minute. I stop and I look back, and do you see my mistake? Yeah. Negative 10. Negative 10. So then 2 negatives, positive. Ah, right? So, because that'd be a little weird for it to come out negative there. So, I mean, it could, but that'd be a little weird. So, square root of 169 over 8. Use your calculator. Square root of 169 is 13. And so, what are those two options? That's minus 3 plus 13 over 8 and minus 3 minus 13 over 8. And what's that? That is, 10 eighths or 5 fourths. This one is minus 16 eighths or negative 2. So negative 2 and 5 fourths are the two answers. Which we could have got more quickly if we factored, but, right, if you're a good factorer, you could have just factored that. Maybe some of you did that. Just take this thing. And right over here, just factor it real quick. If you're good at factoring, you could just go, oh, yeah, equals 0. That's going to be 2x, 2x, 2 and 5 would be 5 and would be 10 and 4. Yes, that's not going to work. So I'm just playing out the FOIL in my head is basically what I'm doing. So 4x and x, 5 and 2 because 6. So 5 and 8. Yeah, so the 5 is going to go here and the 2 is going to go there. So, and plus minus. Yeah, so that's the right factorization right there. How do I do that? I'm basically just thinking this out in my head. I'm just going 4x squared plus 8x, boom, boom, minus 5x minus 10. Oh, yeah, that makes plus 3 in the middle. That's the right thing. So then you just set each one equal to 0. 4x minus 5 is 0. X plus 2 is 0. Jump over the 5, jump that over. So 4x is 5, divide by the 4. There it is, negative 2. Same two answers. So you can just factor it, and factoring means just trying different FOILs until you can get it to work. And the more you do that, the faster you'll get at doing it. You know, like anything in life, right? The more you do this, you can kind of do this in your head, and you'll be able to factor. You need to get that skill. I remember my daughters a couple years ago taking pre-calc from Mr. Jameson's, telling me how much they hated factoring, and one of them, that was her last math class ever, so I said, that's fine. But the other one likes chemistry, so I said, well, honey, for you got to learn to factor. So if you want to go on, you got to learn to factor. And that's just practice. Just do the FOIL, do the FOIL, do the FOIL, do the FOIL. You get better and better. Good there? Questions on that? Were the answers there? 5 fourths negative 2. 5 fourths, yeah, there it is, D. See, they're not all none of the above, right? Let's take a look. So remember the graphs. So one of the graphs was the 1 over x graph, which ended up having asymptote right there, and a branch here and a branch there. Remember the 1 over x graph? Looks like that. With the two asymptotes. So that's what we're looking at here. This is basically the 1 over x graph, but some stuff has been done to him. Okay. So how do we know, like, what's up with him? Has he been flipped anyway? He's certainly been flipped, right? Because normally, so if you have on your full sheet, even right now, if you add to your paper this graph, that would be wise. And just have it right before your eyes on your full sheet of notes for the final exam. Then you look and go, okay, how does this compare to that? Oh, it's been flipped, hasn't it? This part's gone up there, this part's gone down there. See how the whole thing's been turned upside down, or you could say sideways, whatever, same thing. It's been flipped, one way or the other, hasn't it? So what causes a flip? A negative multiplier, like that, or like that, or like that, not A. A doesn't have a negative. A has a positive number on the top, no way. Good so far? So it's either B, C, D, or none of the above. So, okay. Now, what else do we do from there?
Where the asymptote line shifted over?
Yeah, where the asymptote lines are, huh? Yeah, remember the center of the asymptote lines? So what is the center of the asymptote lines? Well, it's right here. Over 1, up 0, right? They're not. You might think, well, they're not showing the other asymptote. Yeah, you're right. They're not showing this one because the axis covers it up. The solid axis is hiding the dotted asymptote line, but it's got to be there. How do I know it's there without actually showing it?
None of the graphs are here.
Yeah, see the graph is conforming to it. See the graph is conforming to it. See how they're getting closer and closer to those dotted lines, to those lines forever? That must be an asymptote line, huh? That's what an asymptote line is, a line of approach. Right? So we know it's there, even without seeing it. Okay, so what then? So how do we do this thing? Well, this is x equals 1, y equals 0. Which one of B, C, or D has x equals positive 1, 0? Well, they all have x is positive 1. And B has everything else you need. It has 0 out here. Is that too fast? Do you not understand all that? So what I could do is I could plug in for you. Like if you think, for example, if you think, you could just test them. If you think the answer is maybe like C, we could test it out. It's not. Here's how you would prove it. What if the answer really was C? Remember how I taught you to make tables? I said you could plug in and find the center point. Remember how you find the center point? Which is this point right here, which we know is 1, 0. Let me show you it wouldn't work for C or D. The center point, what do you plug in for X? Yeah, 1, because that's what makes X's world 0. Remember us making those tables? We didn't just plug any old points in. We plugged in the center point in particular. And how do you find the center point? What makes X's world 0? So you make X's world equals 0. Now, what's X's world? This right here. Whatever's right next to him in his little world. Underneath the bar there, inside the absolute value, in the square root, whatever. Wherever he lives, right next to him. So what can you plug in right there to make his little world 0? Obviously 1. Now when you plug that in, minus 1 over 0, right? That bottom's going to become 0 when you plug in 1. So what's that? What's minus 1 over 0 minus 2? Yeah. Remember when you divide by 0, it's undefined? Remember that? So this is undefined minus 2. Right? If you divide that on your calculator, it's undefined. What's undefined minus 2? Well, it's undefined. But, remember I gave you a special rule to help you out, make life easier for you on these? I said, pretend. If you want to find the center dot, pretend that undefined is actually just 0. It's not really. It's really undefined. But if you pretend, here we are pretending in math, you'll get a negative 2 over 1 down 2. Now, what is that? That would be the center dot if the graph was really C. It's not C, therefore. Do you see that? Am I going too quick? I feel like I'm not communicating with you. So I look in your eyes. I'm not sure I'm getting across. And this is a hard one. So in other words, you plug into each of these equations, plug in what would make X's world 0, plug in what would make X's world 0, and for all three of them, it's 1, 1, 1. And when you do, pretend the bottom becomes 0, pretend that's 0, so what would Y equal? The other number. Like in this case, the center would have to be over 1 down 2, right there, and that's not the true center on the graph, is it? So the answer is not C. It's not D for the same reason. For D, it would be plus 2, because they have a plus 2 out there. So you see why it's B, because B has nothing out there. So it's really 1, 0. That's the real center. Nothing out there. That's the true answer. B it is. Is that okay? That makes sense? Questions on that one?
What does the negative 2 do again?
Well, because the negative 2 ends up divided... the negative 2 flips it upside down.
Okay.
Yeah, the negative 2... Yeah, because you might wonder, like, why isn't this the answer? That's very similar. It's because it's been flipped. See how the original, the 1 over x, this is why you want to have this on your full sheet of notes for the exam final next week. 1 over x, the branches are there and there, but see how they've been moved to here and here. That whole graph's been turned upside down.
And then just the number itself, 2, was where it crosses, which is why it goes up 1, 2, and then that's where it crosses?
Oh, that's just a coincidence.
Oh.
Yeah. The fact that it crosses right here, too, you mean?
Yeah.
Yeah, don't focus on that. That's just a coincidence. Yeah, so what we notice is there's got to be a negative. This could have been a negative 3 for all we care. It's just the fact that it's negative that makes it flip upside down. Right, because that's a negative multiplier. That made the graph flip upside down. Remember when you multiply a graph by a negative number? That flips it vertically. So that's what made the graph flip. And then the 0, the 1, 0 is the center. Okay, let me jump in. We've only got a couple minutes left. Let me help you. So remember Y equals B to the X plus A. Isn't that how I wrote it? I'm trying to remember the formula. Yeah, I think that's it. So remember that is generally the A is where the horizontal asymptote is. So at A is the horizontal asymptote, and then the graph goes like that. Remember how that works? So you want to have, again, this is what you want to put on your full sheet of notes for the final. Would you recognize this as exponential? See how x is up in the power zone? So you'd recognize that's what exponential means. Remember that as you go into calculus, because there will be a whole different way of doing the derivative for exponential versus non-exponential functions. So you want to know, what is an exponential function? It's not just that it has exponents, but that x is in the power zone. X is up there. So it's exponential. The graph rockets up to the right unless it's been flipped or something. Now, has this one been flipped in any way?
Yes.
And it's so vertically, sideways, how's it been flipped?
Oh,
So,
yeah, exactly.
so how's it been flipped? Up and down or sideways?
Sideways.
Sideways.
Why?
Sideways. Everybody see it's been flipped sideways, right? Because instead of going up to the right, it's going up to the left, isn't it? So the normal graph, normally if there's been no flips, it'll normally go up to the right. Okay, so what makes a graph so it's been flipped? Flipped sideways. So we talked a lot about flips and stuff. What makes a graph flip sideways?
Negative.
Negative where, though? On x itself, wherever x is. What makes a graph flip vertically? Negative in the very front. We'll get to one of those in a bit. So, well, not today. But a negative in the very front makes a graph flip vertically. Negative on an x makes a graph flip sideways. Remember all that? Okay, so I'm looking for an equation that has negative on the x. Does he have negative on the x? No way. Does he? Yes. Does he? Yes. Does he? No. No way. A and D are out. It's either B or C or none of the above. So now, which one of those is right? Well, the number out here is supposed to be the horizontal asymptote. What is the horizontal asymptote?
Negative 2.
2, right? Right there, 2. So it's going to be 2. So it's going to be C, isn't it?
So with the vertical asymptote, you 1. What negative 1?
There is no vertical asymptote.
Okay.
It goes up forever, but it doesn't go up in a line. And so the answer is C by identifying the horizontal asymptote and the negative on the x flipping it sideways.